Welcome to the Base Face Network.
Hello all students, I am teacher Fitra and today we are going to learn about the rate of reaction. However, I'm sure all of you are wondering why I'm showing a video of frying chicken just now. Actually, the purpose of teacher presenting that video to you is to share with all of you that we actually frequently apply the rate of reaction in our daily life. For example, when our mothers fry chicken, there is a specific reason why the chicken is cut into small pieces. Do you all know that small-sized chicken pieces cook faster compared to the whole chicken? In the context of the rate of reaction, small-sized chicken pieces have a large surface area exposed to heat. This cause effective collision between the chicken particles and the heat source to increase, resulting in an increased rate of reaction. So, small-sized chicken pieces can be cooked quickly compared to the whole chicken. Before we delve into further learning, let's explore the learning objective that you can achieve from this topic. First, students can classify fast and slow reactions that occur in daily life. Second, students can explain the meaning of the rate of reaction. Third, students can determine the instantaneous rate of reaction. Last but not least, students can investigate factors affecting the rate of reaction through experiments based on the 4 factors that will be explained after this.
Firstly, you need to know that the rate of reaction is divided into 2, namely fast reaction and slow reaction. Fast reactions are chemical reactions that occur in a very short time. The combustion of a natural gas is an example of a fast chemical reaction, while the changes happening over a long period of time are considered as slow reaction. There are a variety of chemical reactions that occur in our surroundings. Did you realize that chemical reactions also occur in our bodies? Do such reaction occurs at a fast or slow rate? So, these are examples of chemical reaction that occur in our daily life. Fireworks, the ignition of matches, and the combustion of gases are examples where fast reaction take place. Rotten fruits and vegetables, the photosynthesis process, and the corrosion of metals are examples where slow reaction take place. Next, how to find the overall average rate of reaction. To find the overall average rate of a chemical reaction, you can use the formula total volume of gas collected, which is your product, per time taken for the product to form. Plug the values into the formula, and the result will be the overall average rate of the reaction. This rate provides insight into how the concentration changes over time, giving a measure of the reaction speed. Keep in mind the units of concentration and time when interpreting the result. But what is the difference between average rate of reaction and the average rate of reaction for the first T1 second? The overall average rate of reaction considers the entire duration of a chemical reaction from the initial state to the final state. It involves calculating the change in concentration of reactant or product over the entire time elapsed during the reaction. On the other hand, The average rate of reaction for the first T1 seconds focuses on a specific time interval at the beginning of the reaction. Instead of considering the entire duration, this method involves determining the change in concentration during the initial T1 seconds. These are the three steps for finding the instantaneous rate of reaction. First, you must draw a tangent to the curve at a specific time. Second, you have to use the tangent to complete a vertically angled triangle. Lastly, you need to calculate the gradient of the tangent to the curve. I really hope that my students do not have any problems calculating the gradient, as you are familiar with this concept in your mathematics subject. I hope you can better understand by looking at the diagram that I have provided. Let's move on to the factors affecting the rate of reaction. There are four factors that affect the rate of reaction. First, the size of the reactants. Second, concentrations. Third, temperature. And fourth, the presence of a catalyst. You can read the brief explanations below to get an idea, as after this, you will watch a video regarding the factors affecting the rate of reaction.
Okay, student, what do you understand by the rate of reaction? According to the Chemistry Form 4 textbook, the rate of reaction is the change in the quantity of the reactant per unit time, or the change in the quantity of product per unit time. During the reaction, the quantity of reactant used decreases, while the quantity of product formed increases. The unit for the mass of solids is measured in grams, while the volume of gases is measured in centimeter cube or decimeter cube. For the quantity of soluble substances, the concentration is measured in mole per decimeter cube. The choice of the unit of time depends on the rate of reaction. For fast reaction, the time is measured in seconds, while for slow reaction, minutes are used. Therefore, these are the units for the rate of reaction that are commonly used.
First, let's start with the size of reactant. Smaller reactant particles provide a greater surface area, which increases the chance for the particles to collide. Thus, the rate of reaction increases. The next factor is concentration. If the concentration of the reactant is increased, the reactant particles become more crowded. Therefore, there is a greater chance of the particle colliding. Thus, the rate of reaction increases. We can conclude that the concentration of reactant is directly proportional with the rate of reaction. The third factor is temperature. Once a substance is heated, the particles move more quickly and they have more kinetic energy. The frequency of collision between the particles increases. Thus, the rate of reaction increases. The temperature also directly proportional with the rate of reaction. The higher the temperature, the rate of reaction increases. The last factor is presence of catalysts. Catalysts are chemical substances that alter the rate of chemical reaction without undergoing any chemical changes at the end of the reaction. Catalysts lower the activation energy and increase the rate of chemical reaction.
After we have learned the topics, the rate of reaction, what can I conclude is the rate of reaction is a crucial concept in chemistry, representing the speed at which reactants are transformed into product. It is defined as the change in concentration of reactant or product per unit time. Understanding and classifying the rate of reaction allow us to analyze and predict chemical processes. We also learn about instantaneous rate of reaction. The instantaneous rate of reaction is the rate at a particular moment in time. It is determined by measuring the rate at a very specific point in the reaction progress. This can be achieved through the method such as monitoring change in concentration of reactant or product over a small time interval, calculating the slope of tangent to the concentration time graph at a specific point provide the instantaneous rate. We also learn about the factor affecting the rate of reaction. The first one is concentration of reactant, second is temperature, third is surface area, and lastly, the presence of. In conclusion, a thorough understanding of the rate of reaction, its classification, and the factor influencing it is essential for designing and optimizing chemical processes. This knowledge is not only aids in predicting reaction outcome, but also contribute to the development of efficient and sustainable chemical reactions in various fields.
Care to listen, I find myself in a shit position. The man that I love sat me down last night.